So this is chapter 8.63, lots of Lewis electron dot structures to draw in this one. It says Lewis structures for each of the following molecules. Identify the instances when the octet rule is not obeyed. State which atom in the compound does not follow this octet rule, and state how many electrons surround these atoms. So we'll start here with NO, nitrogen, 5 valence electrons, oxygen 6. We got an odd number of electrons right here. So it's going to be nitrogen bonded to oxygen. That uses up 2. That leaves us with a 9er. 2, 4, 6, 8. We're not going to work out very good there. Let's try double bond. Let's see if that helps at all. And double bond O, that uses up 2 minus 2, so 4 gone, so 9, 8, 7 electrons left. 2, 4, 6, 7. So we end up with an odd number of electrons right here. So this does not obey the octet rule. And it turns out on my choice right here, oxygen ends up with 1 electron, which is really weird and probably will never show up again. Next one is BF3. So boron has got 3 valence electrons. That's in group 13 right here. And then fluorine, of course, has 7 valence electrons. It's in group 17. And then that's times 3. 21 plus 3 is 24 valence electrons. Put the least electronegative atom in the middle. And, of course, fluorine is the most electronegative atom, so keep him far, far away from that. And then we'd have 2, 4, 6 used up in there. We'd have 18 valence electrons left. 2, 4, 6, 8, 10, 12, 14, 16, 18. Completes the octet, but it leaves, for the fluorines, but it leaves boron electron deficient. And it turns out that boron can be electron deficient once in a while. And so the answer is no, we do not obey the octet rule here, and boron ends up having only 6 electrons around. Boron's one of the weird exception guys that can do that once in a while. ICl2. Minus 1. Iodine, 7 valence electrons on the periodic table. Chlorine, 7 valence electrons on the periodic table, times 2 plus 1 more. 7 for iodine right here, 7 for chlorine, multiply by 2, and then you get 1 more because it's got the minus sign right there. So 21 plus 1 is 22 valence electrons. Put the least electronegative atom in the middle, and then put the chlorines around it. 2, 4 are used up, minus 4, that gives us 18 remaining. Well, let's see how we do here. If we went 2, 4, 6, 8, 10, 12, 14, 16, we'd have an extra pair of electrons. We can put extra pairs of electrons on central atoms that are 3rd period and below. And lo and behold, iodine right here is in the 3rd, 4th, 5th period. And so iodine could have an expanded octet. So let's try that. 2, 4, 6, 8, 10, 12, 14, 16, 18. And then we'd put brackets around it. We'd put a little -1 out here. And we do not obey the octet rule. Iodine breaks the octet rule. It has an expanded octet and has 10 valence electrons in this case. And it can do that because it is 3rd period or below. All right, let's see. Next one is, looks like I did one number from 74. Oh, shoot. You got number 64 in there as a bonus. 64, letter C. I jumped to that one. Let's go back to 63. Oh, I'll stick with 64. That's where I'm at right now. I'm at 64 the whole time. That's the one I've been on. So let's continue with number 64. This one is OPBr3. And then it says P is the central atom on this one. And so in this one, oxygen would have 6 valence electrons, phosphorus 5, and then bromine 7 times 3 is 21. So 21, 31, 32 valence electrons. I think I did that math right. Bromine right here is in group 7, 17, phosphorus 5 right here, and then oxygen in group 6 right here for 6. So 32. And it says P is the central atom. It is the least electronegative, or pretty close to that anyway. Bromine might be right even with it, but it tells us that phosphorus is the central atom. And then, let's see, to bond everything else around it, we'd probably have a bromine here, a bromine here, a bromine here, and then we'd need an oxygen right here. And let's see, that uses up 2, 4, 6, 8 valence electrons there. That leaves us with 24 valence electrons left. So 6, 6, 6, and 6. That would give us 6 times 4, 24. So let's put those electrons around each one of them to complete the octet. And then we have an octet on phosphorus. We've got an octet on everything else around it. And so, yes, it does obey the octet rule. and everything has 8 valence electrons around it. Last one is XEF4, so this is 64, number letter E right here. XEF4, a formula that's got xenon in it. That's quite unusual, ladies and gentlemen. Xenon has got 8 valence electrons because it is a noble gas, one of the few ones that makes a compound. And then fluorine, of course, the trion source reacts with the elements. That's the only reason I can react with it, is because it's so violent. 28 plus 8, because there's 36 valence electrons. Put the Xe in the middle, bond the fluorine atomals around it. That uses up 2, 4, 6, 8. 36 minus 8 gives me 28 valence electrons remaining. If I go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, that gives me 4 valence electrons remaining. Those can go on a central atom as long as the central atom is 3rd period or below, and xenon is 3rd period or below. So we've got 2 extra sets of valence electrons. So it does not obey the octet rule, and xenon ends up having 12 valence electrons around it.